We already know how many pictures. It's how big can the pictures be? Pick up your colored pen. For today's warm-up, we're going to start with part B and work our way to part A. How wide can each picture be? Okay, so we'll be using the equity bars a lot today, so I'll start now. I've got number 9, 13, and 15. Number 9, where are you? Number 9, number 13, where are you?
15.
And 15, good. Number 9, what'd you get? Well, it wasn't an optional question, and the clock's been running for over 10 minutes. So you should have gotten something. Chanel? Still trying? Dave? You haven't finished yet. Okay. Marcus?
2 and 1/3.
Okay. Okay. So we have some proposals. Stacy? Okay, so we got 3 different proposals.
I know.
The correct answer is 1.5 inches. So what was the equation that we needed to use? I'm going to show you what I think the equation should have been, but there's actually quite a few that you could have used. But I specifically asked you for an equation, so there should have been an equation. So let's figure out where this equation comes from. You should already know, because we did a question very similar to this last time we were together. So there should have been a process by which you learned from last time and then applied what you learned to today. If it was still a struggle, that's fine. It's only 2 times you've seen something. But now you're going to see it again. And now the 3rd time I show you on another day, there should be a much clearer path from starting to finishing. So this time I provided you with a picture, however, I left elements out of the picture. And you had the job of filling in the details. But there was something about my picture that maybe confused you a little bit. There could have been a slightly better picture. Does anyone know what a better picture might have been? Marcus?
Like without actually filling in the place of an X.
Okay, well, all right, but I wasn't going to fill in the numbers, so I just want the picture. And so, but there's something about the picture that maybe might have confused some people. So let me ask you this. Within the scenario, are we talking about things going across the page, or are we talking about things going up and down the page? So we got 6 people who have an idea. Catalina, what do you think? Across. Kaylee, what did you think? So we're talking about things going across the page. So in actuality, we did not need any of this. We just needed the part of the picture that went across the page. So let's follow the same process that we did last time and see where it gets us. What's the overall distance from here to here? Gary?
8.5 inches.
It's 8.5 inches. So we know the total distance is 8.5 inches. So we know that everything needs to add up to 8.5, and now you see where that comes from. Now the pieces. What about the distance from here to here? What is that distance going to be? Chanel? 1 inch. Where do you see that? I don't see that anywhere in the diagram. Very good. It says the left margin is 1 inch. That's 1 right there. What about this distance from here to here? What's that distance going to be? Alex? That's 1/4 an inch? Because that's 1 inch, and 1/4 of an inch is much smaller than that. You think that's 1? Ah, say that one more time.
We don't know what it
And when you're sitting in this classroom, when we don't know something, what do we write? Michael? Good. What should we use? Might as well just keep it x. So that's x. Now back to Alex. What's this distance from here to here? That's the 1/4. So I'm going to write that in small right there. What about this distance from here to here? What's that going to be? Kaylee? That's another x. And now you should see what's happening here is that's a 1/4. And this is another x. And what about this final distance from here to here? Tristan? That's 2.5 because it says the right margin is 2.5 inches. So it's the same exact scenario as last time with some small differences. Last time I was asking you for the spaces in between. This time I'm asking you for the width of the pictures. And so you add up all of these, and it must equal 8.5. Solve the equation. It actually works out to be very simple. What's 1/4 plus 1/4? What's 1/4 plus 1/4, David? And what's 1/2 plus 2.5?
3.
And what's 3 plus 1? Is that really that hard? So some of you were asking for calculators and all this because you immediately look at this and you get intimidated. But why? You already know what to do. The intimidation is because you're used to being intimidated. But you shouldn't be anymore. You should be now developing some confidence and some ideas of a pathway from how to get from this complex scenario to an answer. Those of you who shared your answer and it was incorrect, I appreciate what you did. Because you chose a pathway, you stuck with it, you got an answer, and you tried. Now, by the end of this year, we should all be able to work through this with great success. But if you don't even make the effort, or you don't even pick a pathway and follow it, then you have another issue, which is you're not doing your job at all. So now, back to the math. Are there any comments or questions about how this was done? So just to make sure you're clear on what this equation really is, this comes out to 3x plus 4 equals 8.5. How many steps does it take to solve that? Hold up the number of fingers that you think it will take to solve that. No, I'm sorry, 2. Yeah, 2. Don't be swayed by me. Yeah, it's a 2-step equation. You should instantly recognize that as a 2-step equation. Subtract 4, divide by 3. It's no big deal. So now next time I give you a question like this, I will expect a great deal of success, not the cricket sounds that I hear like I did today. Any comments, questions? Okay. Last time we were together, we developed the foundation idea of what an inequality was, how to identify solutions, how the whole idea of inequalities works. Today, we're going to start learning how to solve inequalities. It's a good news, bad news situation for you guys. The good news is you actually already know how to solve inequalities. The bad news is if you were struggling with solving equations, then you're going to be still struggling with inequalities. But hopefully, the fact that you're going through all of it again in a just slightly different way will help you improve what you didn't get before. So, solving one-step inequalities. We use all the transformations that you learned already. What was the magic word that guided us on transformations? It was a magic word that began with the letter I. What was the magic word? 4 light bulbs, 5 light bulbs. Cheyenne? Inverse. That's what guides us on transformation. My other students who had their hands raised, I'm hoping that you were thinking the same thing, and I appreciate you volunteering. Inverse. That's what guides us on transformations. So all the inverse techniques that you've learned will still apply. That's the really good news. I've also told you that algebra is about the details. And so there's one detail that we're going to add on to what you learned before. And it only applies to inequalities, and it only applies to certain inequalities. Here is the detail. If you're doing a transformation, and you multiply or divide both sides by a negative number, you must flip the symbol. This is the kind of detail that separates success from failure. I want you to fast forward in your mind to next week. You're going to have a quiz. And on the quiz, you're going to have to solve inequalities. And you're going to be doing it, and on it is going to be an inequality that you have to solve by multiplying or dividing by a negative number. And you don't flip the symbol. So what's going to happen? You're going to get it wrong, and there's going to be a bunch of them, and so you're going to get an F on the quiz. So that one detail will separate you from success. So the question is, who will remember? The answer is everybody. During a transformation, if you multiply or divide both sides by a negative number, you flip the inequality symbol. So, let's put that into practice right away. Let's see what that means for us. Now, example 1. You don't have to copy these instructions, but make sure you read them because you're going to see those same exact instructions over and over again in my lesson, in the textbook, workbook, quiz, test. It's going to say, solve each inequality and graph the solution. So that's why we spent the time last class learning how to graph. So now we need to solve this. So now let me take a quick side trip. Let's get rid of this for a moment so we can focus. And I'll bring that back in a second. And so let's pretend that instead of it saying negative 6x is greater than or equal to negative 24, it says negative 6x is equal to negative 24. How do we solve that equation? Good, that's what I should see. Tons of hands up. Jesse? Divide both sides by negative 6. You said that beautifully. This cancels out, and we get x equals, and now divide a negative by a negative, we get a positive 4. And so we're done. X equals 4, we get one solution, we're done. Hallelujah. That's for an equation. An inequality presents some challenges on top of that. So this is actually not what we're doing. But we are going to use the same skills to do the inequality. So we are going to divide both sides by -6, just like Jesse helped us understand. And so we divide by -6. But now that rule that was on a banner, gigantic, should be a flashing neon sign in your mind. If you multiply or divide by a negative number, flip the symbol. If you multiply or divide by a negative number, flip the symbol. If you multiply or divide by a negative number, flip the symbol. I am multiplying or dividing. In this case, I'm dividing by a negative number, which means that I must flip the symbol when I'm done with this step. So this is going to cancel out. I'm going to have the x, but now I must flip the symbol. And now -24 divided by -6, we already know, is 4. And so we now have an algebraic solution to the inequality. Does anyone have any questions about that? Any concerns? So now we must graph, because the picture really illustrates all the solutions better than the algebraic statement. And so, like you learned last time, we pick a spot to put the 4. That's always our starting point. You can put it right in the middle. And then just write in 5 tick marks total. So that's 5, 6, 3, 2, and graph. I'm not going to spend a lot of time talking to you about graphing. At this point, it's automatic. You're doing it every time, and you should just be able to do it along with me. I shouldn't have to talk you through it, and there shouldn't really be any hesitation. But I will ask one question this first time. What kind of circle should I put on top of the 4? Okay, Chopin? Do you agree with that, Stacy? Yeah, it's going to be a closed circle. Very nicely said. Could someone explain why it has to be closed? Amari? Yeah, bar underneath means closed. Very good. And now we need to shade. At this point, shading should be pretty instinctive for you. X is less than 4, which means all the numbers less than this number need to be shaded in. And drawing the arrow is not optional. You must draw the arrow on the end. So, clear circle. Make sure it's easy to tell whether it's filled in or not. Shade in, and make sure you have an arrow. Any questions about that? Good. So the one detail that we really needed to pay attention to was, since we multiplied or divided by a negative number, we flipped the symbol. Any questions? Good. Let's try another. X plus 10 is less than -23. You should be thinking x plus 10 is equal to -23. And how you would solve that. How do we solve this one, the equation? Alex? Said it perfectly. Subtract 10 from both sides. Draw our line, cancel, and we get x equals -33. And we're done. But this is not an equation. So I'm using the equation just to get my mind working in the right way. And so now I'm going back to the inequality. And we're going to apply the same logic. Subtract 10 from both sides. This cancels out. X is less than -33. Did we multiply or divide by a negative number? No. So we don't touch the symbol. It stays the same direction. Yes, there's a negative number here, but that's not the rule. The rule is if you multiply or divide both sides by a negative number, we subtracted from both sides. That's not the same thing. So this is the algebraic result. Now we need the graph. Our starting point is negative 33. Put a negative 33 somewhere near the middle. This would be negative 32. That's negative 31. That's negative 34. That's negative 35. Negative 30, negative 29, and so on. I'm just skipping because it'll get too crowded and it'll just look like a big mess if I fill in all of them. And so again, graphing should be easy at this point. Open circle because there's no bar, just like Amari said. And now we shade. Any comments, questions, any concerns, anything at all about this? So the detail only applies in certain cases, but the sign should be a flashing neon sign in your mind. Just always there flashing so that if it comes up, you remember to do it. Any comments or questions? All right, let's take a look at one more before I turn you loose on your own. So again, m over 3 is equal to 2.4. Don't pick up your calculator. Do not pick up your calculator at all. But how do we solve m over 3 is equal to 2.4? How do we solve that? Got a bunch of people who know. Excellent. Laurel? Do you agree with that, Chanel? Okay. So times 3 on both sides. And we then go ahead and solve the equation. But we're not doing an equation, we're doing an inequality. So we apply the same logic because it is the same idea. So we will multiply both sides by 3. So do we flip the symbol? Because I'm multiplying.
Yeah. Oh, no. A negative number.
No, it's got to be when it's a negative, multiplying by a negative number. Now, what if this was a negative?
Then you flip it. Yeah.
Nah, no, you don't.
Well, yeah, it has to be a negative.
Because it's only when you multiply both sides by the negative number. So if I have to multiply by a negative 3 on both sides, that's when you flip it. That's the difference. So you really have to pay attention to what you're doing. So this cancels this. M is less than or equal to, don't pick up your calculator, because you don't need it. You have two different ways you could do this. You could do 24 times 3 and then move the decimal back. Or you could do 2 times 3 and 0.4 times 3 and add them together. But either way, you should be able to do it mentally. So what's 2.4 times 3? Michael? Is that what you got? What did you get? Oh, you said yes? 7.2. So that is the algebraic results. Now let's graph. Put 7.2 somewhere in the middle, doesn't really matter where. This would be 7.3, 7.4, 7.1, 7, 6.9, 6.8, and so on. Close circle, and shade. Please understand, just because I'm not spending time discussing the graphing doesn't mean it's not important. It's very important. So of course you have all the graphs for everything that we're doing. Does anyone have any comments or questions on solving an inequality? All right, checkpoint number 1. You're on your own. Solve these two and graph them. So solve, find the algebraic solution, graph it, and then move on to the next question. You've got 3 minutes for 2 questions. That's a minute and a half per question. to the equity bars. Part A, I've got number 1, number 4, number 14, and number 23. Number 1, number 4, and number 14. Where's number 14? Okay, what'd you get?
I got 16 with the open circle shaded.
Well, I don't need you to describe a graph. I need the solution.
16.
Okay.
No. R is less
Just speak up a little bit. Nobody can hear you.
than 9. R is less than 9.
Okay.
R is less than
Okay. The correct solution is R is less than 16. R is less than 16. If you said R is 16, unfortunately that's not correct because we're talking about inequalities. And R is less than 16, which actually means R could be 15, 14, 13, 12 and a half, 10.9. Okay? And your graph, unfortunately my colors are not translating very well on the projector, but this is an open circle and it's shaded to the left. What about part B? What does it come out to? Equity bars, here we come. I appreciate the volunteers, but we're going to stick with this for now. We got number 2, number 10, and number 21. Number 2, number 10, and number 21. Where's number 21? All right, go.
X is less than or equal to 24.
Okay. So I think you said the same thing. Okay, Amari? Okay, so we do have some disagreement, but it is x is less than or equal to 24. And if you put x is greater than or equal to 24, then unfortunately you got it wrong because you didn't follow that big neon sign that's supposed to be flashing in your head. That says if you multiply or divide by a negative number, you flip the symbol. And there's the graph. It's a filled-in circle on the 24, and you shade in everything to the left. Give me a thumbs up if you got both questions correct. Thumbs up if you got both correct. Good, put your thumbs down. So let me back up for a second. How do you solve the first one? Part A. How do you solve something that looks like that? What are you supposed to do? Amani? Good. Multiply both sides by the reciprocal. Excuse me. Multiply by the reciprocal, and what is the reciprocal again? 4 over 3. So you multiply by 4/3, multiply by 4/3, that cancels out, and you get R is less than 12 times 4 divided by 3. 48 divided by 3 is 16. That was a one-step inequality. That is it. So, and then of course you saw the graph already. What about part B? I'm sorry, I went too fast. Are there any questions on part A? Part B, how do you solve that one? Kaylee, how do you solve that one? Multiply both sides by -3. You said that beautifully. Multiply by -3. Multiply by -3. That cancels out, but what did we just do? That's important, Jesse. And so what do we have to do? Flip the symbol. X is less than or equal to, and now -8 times -3, positive 24. Any questions or comments about either of these? Good, let's take it to the next level. Example 2. So I'm going to do something different with part A. It's a bit of an unusual case. 10 is greater than or equal to negative x. So, I'm going to give you 1 minute to team talk to see if you can come up with something that we can do to solve this inequality. At the very least, figure out what makes it unusual compared to the ones we've done already. So 1 minute team talk, ready, go.
Well, yeah, it doesn't matter, but that's the weird thing about it.
That's the weird thing, but I think it's like any number who has like a regular number next to the x. So like, we know we have one next to the x, basically next to the x. So it's just really going to divide next to the regular number. Yes, we need real numbers. I think that's why. And then, I don't know, we do have that. We need to find.
So divide, I think it's dividing on both sides.
It's going to be the same thing. 10 is going to be
Okay, so what did we come up with? You have some ideas? We'll start here, 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 and here. Start right there. What did you come up with?
Well, when we get our answer, we'll multiply answer by negative f, right? Just the negative.
Okay.
It's like negative 1, it turns 1, or it's
Okay. So you were focusing on this right here?
Yeah.
Okay, it's good thought. We'll come back to that. What did you guys come up with?
That the x is actually a number because it has a negative sign, so it's going to be 1 and also it's a number sign.
Ah, you caught on to something important. Who was next? Over here, Gary and Cheyenne and Tristan. What'd you come up with?
Since there's only a negative symbol, that means there's a negative 1 in front of x, so divide both sides by negative 1.
Okay. All right, so all good thoughts so far. Yasmin, what did your team come up with? Okay, so you had a similar thought to this team up here. Kaylee, what did your team come up with? Okay, so you picked up on something that a few other groups said. Okay, so everything that everybody said was important. Most important is what Kaylee, Yasmin, and Gary pointed out, and what Marcus pointed out. Marcus is their team was the only one who caught on to the fact that the x was on the right-hand side. So there's actually two things that are making this a little unusual. So let's address the first issue, the simpler one, what Marcus said. How do we get the x, the variable, to just come over to the other side? We can use the symmetric property, even though it's not the symmetric property of equality, we can use the same idea and flip the whole inequality. But you have to be careful because the point is pointing at this, which means when we flip it around, it still has to be pointing the same direction. So we're going to flip this to here, but the point has to flip also. You can't just switch them, you have to flip the whole thing. Okay? So now we have it in a nicer form, but what three teams pointed out was this fact, that is actually a negative 1. And so, Yasmin, what did you guys say to do? So that's a negative 1. Well, what if it was a negative 2? You would divide both sides by negative 2. If it was a negative 8, you'd divide both sides by negative 8. It's a negative 1. Divide both sides by negative 1. But what did we just do that's really significant? Jesse pointed it out before. Let's see if Michael can point it out now. We're dividing by a negative number on both sides, which means we have to flip the symbol right when we're done with this step. So now we get this. And so here is the algebraic results of solving that inequality. And now we just need to graph. And again, I'm going to go quickly through the graph. You need to do it as well. And at this point, you should be feeling extremely comfortable with graphing. Somewhat effortless, but you have to pay close attention to which way you shade.
I just think the point guys are
Okay? Any comments, questions on part A? And I'm very proud of the teamwork that you guys put in. Okay? I'm very impressed, and that was excellent. Any comments, questions? Okay? Another unusual case. I don't want you to copy it down, I just want you to look. What's unusual about part B? Don't copy it, just look. What's unusual about it? Maybe there's nothing unusual about it, I don't know. Adriana? Okay, so there's decimals. So that's something we didn't deal with. Cheyenne? Okay, so the variable's on the right side again. But now we know how to deal with all of those. What will happen if we were to solve this? What significant detail must we pay attention to?
the number that's next to the variable
Is
negative 0.25.
good, so it's a negative number. What are we going to do when we solve this?
Are you gonna add, divide 0.25 on both sides?
Are we?
No, actually we gotta add.
So we're going to add it on both sides?
Yeah.
Chanel? We're going to flip the symbol. Well, now go back to what he was trying to say. What are we going to do? We're going to divide both sides by negative 0.25. So that's what he was trying to say, but he was making a mistake with the negative sign. Excuse me, sorry. So we divide by whatever number's there. Divide, you don't have to write this down, I'm just illustrating so you see that we just divided by a negative, so we have to flip the symbol. Okay? We would end up with the h on the right, and then this ends up being a negative 17. Don't worry about that, doesn't matter. And then we flip the whole thing around. H is greater than negative 17. Okay? And then we would go ahead and graph. But we didn't need to do the whole example. I just needed to point out that decimals are addressed the same way that anything else is addressed. Any comments or questions? Good. So let's see how you do on your own. Checkpoint number 2. You got 3 minutes for 2 questions. Let's see how we did now after seeing some unusual cases and putting it all together. To the equity bars we go. Let's see how we did. So we've got numbers 1, 4, and 17. 1, 4, and where's 17? Good. Go.
5 and a half is greater than 2.
Okay?
5 and a half is greater than
Okay?
T is less than 5
So I would accept all of those. T is less than 5.5, or 5.5 is greater than T. But if you get the variable on the right side, you want to flip the whole thing around so it's on the left. And here is what the graph looks like. It is an open circle on 5 and shaded all the way to the left. What about part B? Back to the equity bars we go. I appreciate the volunteers, but we're going to get everybody involved if we can. And so we got number 2, 6, and 19. Where's number 2, number 6, and number 19? Go.
D is greater than 7.
Okay? Okay, so we have a disagreement. So you agree with her. So could I get a volunteer to chime in and maybe try and even out the playing field? Caleb?
D is greater than -2.
Is that what you said, Caleb? So D is greater than -2. And here's what the graph looks like. And it's a little bit hard to tell, but that's an open circle and it's shaded all the way to the right. Does anyone have any comments, questions before we put it all together to apply it to real world scenarios? Any questions about this? Anything that you've seen so far? I'm going to put up a real world scenario. You write the number of the example, and then you do not copy the example, you will read it to yourself. Do not copy it. Read it to yourself. So we have this fantastic character named Jill, and she's got a $20 gift card to a store. She wants to buy a supply from the store, and the supplies cost $4.30 each. How many tubes can she buy? Now, I'm willing to bet that if I gave this to you as a warm-up question, and I didn't really tell you what to do, I just said, find the answer, you guys would have a way to figure it out. You'd probably figure it out pretty quickly. But if we did that, we would miss several details and we would miss the point. So let's do this in a way that actually gets us the details and reinforces the point. You might not get it until you get towards the end. So let's start with constructing an inequality. Write and solve an inequality. We need a starting point. Can someone pick a piece of information that might help us with a starting point? What would be a starting point to write this out? Jesse, what do you think? That's what I thought. I thought, let's start with the 20. Now I'm going to ask you some questions. Is 20 the most she can spend, or is that the least she can spend? Is that the most she can spend or the least she can spend? Marcus? Alex, you agree with that?
Yes.
Okay. So if that's the most she could spend, and we need to put an inequality symbol, which symbol would we use? Would we use this symbol, or would we use that symbol? If 20 is the most, which symbol is going to be the one? This is the greater than symbol. This is the less than symbol. Which one do you think it's got to be? Tristan, what do you think? David, what did you think?
Less than.
Yeah, it has to be the less than symbol because you learned two different ways to remember how the symbols work. The alligator eats up the bigger number, and we just said that that's the most she could spend. Now, the next question. Can she spend exactly $20? Can she spend exactly 20? She could spend at most 20, so she could spend 15, she could spend 18, she could spend $19.20. But can she spend exactly $20, Garion? Yes, she can. And so what does that mean, Garion?
That means you have to put the line under the less than symbol.
And Garion caught on very quickly. You have to put the line underneath if this number is also one of the solutions. So you have to put the bar underneath in this case. There are cases where you don't have to put the bar. Now we need to figure out what goes here. Anyone have any ideas already? Got some light bulbs going off? Some other ones going off? Yasmin, what do you think goes there? Just couldn't hear you, that's all. It's a big, giant room. Okay, so the $4.30 is going to go over here. So do you think we just put 4.30 and that's it? So the statement is 4.3 is less than or equal to 20. Again, just can't hear you and nobody up front can hear you either. Why? Very good. So we have to have a variable. And the variable, and it can be anything that you want, it could be x, it could be n. X is going to be the number of tubes that she buys. And so since each tube costs $4.30, we multiply that by the number that she buys, and that tells us how much it costs altogether. Whatever she buys, it has to be less than or equal to $20. Does anyone have any questions about how we set this up? Now let's go ahead and solve it. Go ahead, you solve it on your own. You should be able to solve that no problem. You don't need any guidance anymore. Solve it. Go. Yes, Steve. Don't worry about that. Just when it says after tax, it means tax already been. So, I paused and gave you a moment to do it yourself, but you should have done this. Do we flip the symbol?
No.
No, we don't flip the symbol. We didn't divide by a negative number. We divided by a positive. So we end up with x is less than or equal to what? X is less than or equal to what? Tristan? Is that what you got? Caleb? Oh, hold on. You got 4.65? Okay. What did you say? Oh. Well, let's put down the 4.65 for a second, and then let's get to Kayla's points, because she read my mind. She apparently has incredible superpowers. So if you sat here and circled this and patted yourself on the back, you unfortunately would be wrong. Kayla, say it again, why this cannot be the answer.
You can't buy 0.65% of paint.
That's right. So how many can she buy? Four or less. So what I had in the last class is someone said, I think we have to round it up. Because if you rounded this, that would round to 5, right? But what would happen if she bought 5? Stacy? I love the way you said that. She wouldn't have enough money. So we can't round it up. And as Kayla said, we can't cut a tube in half and buy part of it. So you must round down. And so in this case, it's x is less than or equal to 4, which represents the number of tubes. And so this is what it means to be in a high school honors class, is that you have to actually think it through. You have to think it through. Okay? Any comments, questions, concerns about how we put this together? Okay, I had another example, but I think I'd rather just let you guys work on your own and team talk afterwards to see if you could figure it out. So checkpoint number 3, don't copy it, read it, and then write and solve an inequality. Okay? You got 2 minutes, and then we'll team talk afterwards to see if we have some agreement or not. All right, you got 1 minute team talk to see if you guys agree, and we're looking for agreement on the actual inequality and the solution.
You need to start. Because I did 475 plus 6. At least I'm writing plus X to show her she can add X Yeah, I know. I was going to use 1.
No,
She
you
gives me
didn't
1
roll.
more down. Wait. At least you can. But don't touch me, bro.
Yeah, I
All right. So, what was the solution that you came up with? What was the solution? Start with Chanel, and then we'll go to Michael, Kaylee, Yasmin. Go. Okay.
X is less than 275.
So you agree. You agree as well. So x is less than or equal to 75, and the inequality was either x plus 475 is less than or equal to 550, or 475 plus x is less than or equal to 550. Are there any comments or questions or concerns? You guys have done an excellent job today. Draw a line across your paper. And we are now entering the last section of the lesson, the homework. And you need to write this carefully. Your homework is on page 83, numbers 1 through 9, and on page 89, numbers 1 through 11. That's a total of 20 questions. We're going to have a quiz next week. And that will be on 2-1 to 2-3, which we just finished today. I'll tell you what day it's on. It won't be on Monday, but it'll be later on in the week.